This evening I'm looking at this Fluke 87 Mark V multimeter I picked up a couple of weeks ago, and it was in non-working order, and it was sold for spares or repair. Usually these meters go for sort of like £150–200 on eBay. They're quite an old model from sort of like the late 90s, I suppose. I have actually got the original version, which is just the straight 87 as you see here in its rubber case. I picked this one up for fairly cheap money, but you can clearly see it's got a damaged LCD display. I'll show you that there. So the LCD has been damaged, and he said he dropped it, and he's pretty honest about the listing. It was filthy when I got it, absolutely filthy. I'll put in another photograph at the beginning of the video, maybe to show you what state it was in when I got it. So I've given it a bit of a clean up this afternoon, and it's come up fairly well actually. It hasn't come up badly at all. It did have a yellow surround. I've taken the yellow surround off. That wasn't yellow, it was like a mechanic's multimeter. I think it was all covered in oil and God knows what. It was absolutely filthy. Managed to clean that up fairly well. And as I say, they had a big scratch on the display. I managed to get most of it out. You might see it if you catch it in the light every now and then. The meter basically works. If you see I switch it on, you see apart from half the displays missing, you see that the meter is actually doing something. So I'm pretty confident there's nothing wrong with the meter itself. Pretty confident that all it needs is a new LCD. And it just happens to have another multimeter that I bought a year ago on an online auction site for the government surplus stuff, and this was a big disaster. I paid about 40–50 quid for this, and when I switched it on, apart from it's got a big bash there where it's been dropped or someone sat on it or something, it came up with an error message. When I went into onto the net and had a look, it said that the error message is a processor error and there's no way of doing anything with it, and it's basically a scrap meter. So this meter was obviously scrap, and the MOD have chucked it up in the auction site because they think someone else would buy it, and I did. So what the plan is to do is to get the good bits out of this meter and place them in the other Mark V. So the first thing I'm going to try and do is get this one apart and remove the LCD display. And once I've worked out how to do that, then I'm going to try and implant the LCD display into the other meter. Now also there's a couple of other things. There's a bit of a graunch on this selector knob. Not the end of the world, obviously it doesn't affect the meter, but I'm going to replace it with this better knob. The whole front panel of this is in better condition apart from the crack here that's been welded up badly. So I might even change that over. I might be able to, if I pop this display out, if I can get this Perspex cover off, I could probably save the front panel as well. But yeah, it's a few scrapes and knocks and bangs on it, but at the end of the day it doesn't really matter. It'd be nice if it was sort of like pristine, but it won't be. It's just like a 25-year-old meter that's obviously done some work. So the first thing I'm going to do is let's get this meter apart. Now it has been apart before. Let's bring the camera down so it can work a bit easier for me to work at a decent angle. So I basically had all the screws out, as you can see. Let's remove. Oh, there's a big posy in the middle here, and I think there were two behind the battery compartment before, but I've taken those out and haven't saved those. So there you go. That's obviously the front panel off. There's the screw. And now we're getting into sort of like the electronic side. This should just fall off here. We've got the sounder on the back here. So the next thing to do is got to try and get this off the main frame, because I can't use this section because, as I said, the processor's scrapped on this. So let's get this apart. So hopefully this should be a fairly straightforward repair. Now you can actually buy these LCD screens sometimes on eBay, and I think there's one listed in the States, but it's like £30 plus £15 shipping, so it starts to make these meters BR really. What I do like about this particular model of meter is it's got a very fast update, so that's also always quite like that on a multimeter, a fast updating meter. Okay, so that's those screws done. There's one down here. Get this one off. I'm hoping this will all fall apart in a minute. Still something else holding it in. Can't see what it is. There we go. Okay, so that just pops off there. That pops out of there. So what I'm going to do, I'm going to take this whole frame and plant it onto the new board, onto the new meter I've just picked up. There's the insides. I'll show you those a bit later on. So that's the sort of like the zebra strip, I think they call it. You don't want to touch those. I think we keep those as clean as possible. I'm going to put those down the bench. Let's take the No, wrong meter. Let's take the other one apart, the one with the damaged display. Break the calibration seal. I know that's the original calibration seal from when Fluke calibrated it. It doesn't say it's Fluke, but might have been a third party that calibrated it, I don't know. Let's see what battery he's given us. Anything nice? Are we unlocked or are we locked? I think we're unlocked, aren't we? Yeah. No, maybe we're not locked. Is that unlocked? Can't even get the battery off. Battery compartment off. Definitely unlocked that way. There we go. What have we got in here? Oh, an RS battery. Okay, let's get that out. So yes, there are two screws in the battery compartment, as you can see here and here. Let's whip those out. Wiggle it apart. It's stuck together with gunge and God knows what. It's coming. It's got a rubber gasket around the side that holds it all together. Come on. I'll force it. Clipped onto. Should just slide off there. I think it's just because it's stuck with. There we go. That's just about to pull apart. God, that's tight. Got to do with a spudger here to get this apart. Come on, you stupid thing. There we go. Gotcha. Well, that was a pig. Okay. So there's the buttons that have just fallen out, and they could do a bit of a clean up. You see they're a bit gungy around the side. You can focus on that. A bit manky. So give that a clean up. So okay, this is the bit that we need to replace. So hopefully, all I'm going to do, like I did with the other one, is remove these screws. Use the other screwdriver. I do like these Fluke multimeters. The nice thing about them, as I said about they've got fast update speed, but they're actually incredibly efficient on batteries. They are really, you can, a Duracell will last you 4 or 5 years, I find in mine, as long as you turn it off and you don't, rely on power management. They're very low consumption meters, especially these particular models and the models below it. Some of the later models are quite heavy on power consumption, so that's always a bit of a thing to bear in mind. So there we go, there's our broken display module. Put that up there. So hopefully, in theory, we should be able to bolt this straight back onto the frame. Everything should locate as per before. Okay, I'm going to pop some screws back in it just to hold it in place. I might actually use the other front push buttons if they're in okay condition, because they won't save me having to clean the other ones up. Always bear in mind that when you clean those rubber buttons, don't remove the carbon off the back of the pad, because that's the conductive part that actually makes the switch contact. So if you're cleaning them, let me just show you, when you're cleaning these switches, don't clean the underside of them, don't clean this side here, because that's a conductive strip. Or conductive pad, and that's the thing that actually makes the switch work in the first place. Okay, so are those 2 screws? Okay, these 2 screws here. Check it's all sitting squarely, which it looks like it is. That's good. And when I've got the last screw in, just go around and nip it up again, make sure it's tight. Good. Just go around, check them tight so it keeps the display flush against the circuit board. Right, okay, so that's basically the front done. Now what all I need to do now is I don't need to reassemble it, I just need to power it up and see if we've got a display that works. So that's the, where's the front display we're using? It's this one here, isn't it? So, I can change that knob in a minute if I can get it apart. So we haven't got the push buttons in at the moment, but let's just put a battery on it and see what happens. There we go, working display. Excellent. So that seems to fix that. All I've got to do now is I'm going to try and get this switch changed and see if we can replace it with the other switch that hasn't got a great graunch across it. So we can get that out of there. You know how obvious, easy it is to get apart, if at all, if you can get it off. It does look like this is like a peg there or something. Maybe it isn't designed to come apart. In which case we could still live with it, but it would be nice if I could get that out. No, it doesn't look like there's any obvious way of doing it. So I think we'll have to live with that. It's not the end of the world, it's just a bit of a scratch through one of these sort of like these marks it's got there. It just looks a bit ropey, but I can probably clean that up as well. Okay, so the next thing to do is to have a look at these other switches. They're the ones that were filthy. These are the cleaner ones, but I'm not sure what condition they're in. Well, they look actually in much cleaner condition, so I think we're going to go with those. So we're going to pop these back into the meter housing, make sure we got it around the right way. That way, that goes in there. Now the next thing I'm going to do is, what's really annoying is if you don't make sure you get all your fingerprints off the LCD display. So when you put it all back together, you can always see a fingerprint on the display. That really annoys me. So I'm just going to do it with my t-shirt because I can't find any cloth in here at the moment. I need to get some more rag. So that's clean on the inside of the actual perspex as well. Okay, looks pretty clean. So a simple case now of just reassembling it and checking it for calibration. So let me reassemble it. It's pretty boring watching me reassemble it, and then we'll power it up and see if it works on all the ranges. Okay, I'll show you inside. Just quick run through. But this is obviously all the processing side of it. This is probably all the A to D conversions and stuff like that. Lower down here, we've got the obviously the main switch. We've got the low current range fuse and the high current range fuse. These Busman fuses are very expensive, so you don't want to be blowing these fuses up. High rupture current, high good protection. You've got MOVs and transorbs and God knows what, and thermistors and things for protection here. So it's all very well protected, and this is what you pay for on a Fluke. You know, you've got a meter that will not explode in your face if you plug it into the mains on AC amps or something like that. We can see here, it looks like there's a current shunt down here. Maybe you can just about see that. So basically, a nicely made unit. This one, as I say, has got a processor problem with it. It's probably this processor here. I'm not entirely sure which part's gone, but I know it's BER and not worth repairing. It's worth probably stripping some bits off it for spares. These switch contacts can fail. Some of these have got like a switch inside for when you select the amp range, it knows you're on the amps range when you're about to check volts, and it will alarm the meter will alarm to warn you in the wrong range and things like that. So it's worth saving these parts. Obviously the fuses are going to save, and probably some of the protection circuitry. I'll probably end up just chucking this in a plastic bag and just having it for spares. You know, so if any part does burn out, I blow something up or something, there's a chance I'll be able to repair it with the insides. So that's it back together anyway. Let me just zoom out a bit so you can see a bit better. And it looks like it works fine. It's AC volts, DC volts, millivolts, ohms, diode test, AC milliamps, AC microamps. I think it's DC microamps here, selectable with the range switch here. So I think what I'll do is we'll just do a quick check with maybe a decade box. So let's get back into frame so you're actually looking at the thing rather than just in the mid-air. So let's get this onto a decade box and see. I've got some leads. We should wire it up and see how it performs. So let me find some leads, test leads. Oh, here they are. I have them somewhere. This will do. So we'll start off with the ohms range because that's easy enough to do. So we put it on ohms range, and we'll connect it to my Time Electronics resistance decade box, which is accurate. So this should be 1k. Yep, perfect. This should be 11k. That's good. This should be 110k, 111k. Sorry. Yep. So that's good. Let's try 1 meg. 2 meg. That's working fine. You can see that display, can't you? Just about. There's a bit of glare. I'll turn that off. Does that help? Let's try it on the lower range. 100 ohm, 900 ohms, 800. So ohms range is working perfectly. So that's reassuring. Continuity test. Make sure that nice loud buzzer. Diode check. So it should. Diode's working. Check's working okay as well. That's good. So we can try it on some DC volts. I'm not going to check it for calibration at the moment because I'm going to means digging all my calibration gear out, and I haven't got time to do that this evening. But let's just connect it up to a supply and see what we get. Now I know roughly how accurate these power supplies are, so I'm going to set this to. This should be about 40 volts. Go to DC volts. No, that's the wrong way around. So we should have 40 volts here. There you go. That looks like it's working fine. And you see what I mean by the fast response of the meter. If I quickly change the reading, it very quickly responds, and there's no settling time on them. They're really nice and responsive, these meters. Maybe I'll just prop it up a bit like that so you can see a bit easier. But they're very responsive, as you see, and it's certainly working on volts range fine. We could try it on the high current range, the 10 amp range. Let's try it. It should bleep at me now. Yeah, that's the warning to say don't plug it into a. If you look at that and you think you're on AC volts, you're putting a short circuit across it because you're on current. So you need to put that to amps. Okay, that's right. Now if it carries on beeping when you do that, it usually means the fuse is blown. So what I'm going to do is I set the current limit on the power supply to, let's set it to about 3 amps. Oh, come on. So I'm just holding the leads together on the thing to get about 3 amps. So this is current limited supply, so I'm not actually going straight across a supply with AC on the amps range. I know the current will be limited, so I should see about 3 amps. And it's because I'm on AC. So you need to select the DC range. I'm on AC amps. I need to press the yellow button. And you see 3 amps there. So it looks like it's working absolutely right. You know, there's nothing wrong with the meter itself. It just that it was the display had failed and just needed a new display. So that's great. You know, it's another piece of junk I had kicking around. The scrap one was kicking around at work for ages. I was thinking, am I ever going to get this repaired, or am I ever going to find another one? So luckily enough, I found another one, and we've got a working multimeter again. Anyway, thanks for watching, and more to come.